So now see here, we see that this part will be plus, this part will be minus, and this part will be plus. So firstly, we expand the first entries. So here the first entry is on minus lambda. So I have written here on minus lambda, and then if I then I have to cancel the row and the column of these entries. So I will get on minus lambda, 2, 2, and on minus lambda. So I have written this part here. Okay. So I have to find the determinant of this part. So that's why I have given this kind of sign, determinant sign. And then this part here, it means minus, because I have written here minus, right? And let's see. Okay. So now we have to work with the second entries of the first row. So then we cancel the column. I mean the first column, and then we cancel the second. We cancel the first row and the second column. So we get 0, 2, and 2 minus 1 minus lambda. So here is that. Okay, 0, 2, and 2 minus 1 minus lambda. And then for the third entries, so for the third entries, this is our third entry. So we just cancel out this row and this column. So we get 0 on minus lambda and 2, 2. So I have written here. Okay, you can see here 0 on minus lambda and 2, 2. And for that, our so this was 2, right? So I have written 2 here, and you can skip this part. I mean this part means plus, right? I have written here this part means plus, so you can still skip this part. Okay, you don't need to write down this part. So now if you try to calculate the determinant, so determinant of 2 by 2 matrix, it will be, you just multiply this way. Okay, firstly this way, and then minus this way. So on minus lambda multiply on minus lambda, so it will be, so Laoshi was trying to expand this, but he didn't explain, he didn't gone through all those. So I will try to just do it by my own, and let's see how this happens. So now let's see. Minus 1 minus lambda multiply minus 1 minus lambda. It will be, so we have on the right side we have 1 minus lambda, right? So on minus lambda, and then on inside we have on minus lambda into on minus 1 minus lambda. That means we multiply minus, we multiply 1 with these two things, so it will be minus 1 minus lambda, and then we multiply minus lambda with these two things, so it will be plus lambda plus lambda squared. Okay guys, and then we have to take minus, so then we have to multiply the opposite way. So 2 multiply 2, it will be 4. Okay, so this is the first one, and for the second one here it will be minus, right? It will be minus because I already told you, like it will be minus here, so that's why it will be minus. And then if you multiply the same way, like 0 multiply this one, it will make 0, and then minus 2 multiply 2, it will be 4. So 0 minus 4. Okay, 0 minus 4, 0 minus 4. And then for the third entry, so it is 2, right? So we have 2 here. Okay, so as you see here, we had 0 here, right? Because we were expanding the second. Okay, if you have a close look here, So see, this 0, we took it here, right? Because we were expanding, we were taking this entry, and we were trying to expand, expand this way. So we cancel out this two, we cancel out this row and this column. So we end up with 0, 2, and 2, and minus 1 minus lambda. So this part is here, right? 0, 2, and 2 minus 1 minus lambda. So as you see, we had 0 here, so we don't need to calculate this further, because 0 multiply anything is 0, right? So you can also, okay, so it is 0, right? 0. So 0 multiply this one, 0 multiply this one, and then here we know that this value, it will be plus, right? Because I already written here. So plus, minus, and plus. So this value will be plus. So let's write here plus. Okay, so plus. And then you see, we had 2 here, right? Because we were expanding, expanding this entry. So okay, so the this 2 is here. So I write down 2 here. So 2, then into, so if I calculate here, 2 into 0, that is 0, and then minus 2 into 1, that will be minus 2, because we had a minus here. So, and then 2 into minus lambda, it will be plus 2 lambda. So guys, can you understand? I calculated the same way before, like from top to, from this way minus this way. So now if I try to expand, okay, if I try to expand, like it will be 1 minus, so lambda multiply 1, so it will be plus lambda, and then minus lambda multiply minus lambda, it will be plus lambda squared, and then minus lambda multiply lambda, it will be minus lambda squared, and then minus lambda multiply lambda squared, it will be minus lambda cube, and then it will be plus 4 lambda. Okay, so yeah, and then this part will be 0, because 0 multiply anything is 0, and here it will be 2 into 0 means 0, so 2 into minus 2, it will be minus 4, 2 into 2 lambda, that will be 4 lambda, right? And then you will get like okay, let's see, lambda square cancel, so you get here minus lambda cube, and then 4 lambda and 4 lambda, 8 lambda, and then another 1 lambda, that means 9 lambda, so plus 9 lambda, and then minus 4 plus 1, right? Minus 4 plus 1, it will be minus 3. Okay, minus 4 plus 1, it will be minus 3. So I think okay, so this we end up with this equation, and I try to expand this. Okay, so let's see here. Lambda cube. Okay, so let's calculate this part. And for, okay, so how do we know, how do we calculate the further, how do we calculate further? Where is the question? Okay, so we have to find the eigenvalue, right? So we we know that on the right side, if we look at the, if we look here, so absolute value of a minus lambda I will be equal to 0, right? So as for now, we have calculated this up to here, minus lambda cube plus 9 lambda minus 3. So it was the value of a minus lambda I. Okay. And then from the formula, we know that a minus lambda I will be 0. So I can write down this way, that minus lambda cube minus 9 lambda minus 3, it will be 0, right? And then you have to solve this equation. So if I take a minus common, so it will become lambda cube plus 9 lambda. So I just multiply my minus on the both side. Okay, so my lambda cube plus 9 lambda plus 3 equals 0. And then if you solve this equation, lambda cube plus 9 lambda plus 3, so factorization calculator, if you use this one, yes, right. So let's factorize them. Lambda cube plus 9 lambda plus 3. So I can let lambda, I mean x, so x cube plus 9 lambda plus 3. So I mean 9x plus 3. Oh, it was plus. So did I make any mistake? Okay, let me do it manually. So if I do lambda cube plus I think there was I think I did some mistake here. Okay, maybe just to calculating this part. So if I follow our Lao Shi, I mean we will get something like this. Okay, we will get something like this part. And I tried to expand this part, and as you can see here I tried to expand this part. Okay, so if I multiply, okay, I need to open it in a PDF file. Let me download. Make it a PDF. So I'll recheck them on my paper. Okay, so where I did mistake, so I'll recheck them. So as you can see, if we multiply this way, okay, as I showed you before, maybe I did some mistake in some steps, so that's why my solution is not similar to Laoshi. But if I try to follow our Laoshi, so our answer will be this one. We will get something like this. Okay, on minus lambda into, oh, okay, I think there was, so guys, did I multiply this one? On minus lambda, on minus lambda, with multiply it with the first, okay, first one. Okay, anyway, so we will get something like this one, okay, and then we will try to expand this and we will try to find some solution of lambda. So if you look here, I have tried this just before starting our group study. So okay, so look here, I multiply minus, I multiply minus with on and on minus lambda, so I will get minus 1 minus lambda, and then I multiply, uh, so okay, not this way. First then I multiply, so okay, if I multiply minus with this 1 and lambda, so I'll get like minus 1 and then plus lambda. Or I could do another thing, like I could multiply these two things first, and then I could change their sign. So if I multiply 1 is 1, and then on multiply lambda, it is lambda plus lambda, on plus lambda, and then minus lambda multiply 1 is minus lambda, and minus lambda multiplies lambda is minus lambda square. And we had a minus sign on the left, so their sign will become reverse. So it will become lambda square plus, so plus lambda minus lambda get cancelled. So lambda square minus 1. So lambda square minus 1. And then we have minus 4 here, right? So lambda square minus 1 minus 4, it will become lambda square minus 5, okay? Lambda square minus 5. And then I multiply the minus this minus 4 and 1, so minus 4, and minus 4 minus lambda, that is plus 4 lambda. So minus 4 plus 4 lambda. So, and then also if I multiply on minus lambda with this part, so on multiply lambda square, that is lambda square, on multiply minus 5, that is minus 5, and then minus lambda multiplies lambda square is minus lambda cube, and minus lambda multiplies 5 is minus 5, minus lambda multiplies minus 5, that is plus 5 lambda. So, and then 5 lambda and 4 lambda, that is 9 lambda, and lambda cube here I have written the first, at the first position. So if I take minus, if I factor out minus, then their sign will become reverse, right? Their sign will become reverse. So as you see here on the next line, I have factored out minus. So, and if I take the minus on the right side, so 0 multiply minus 0 multiply minus 1, that is also 0. So I can get this line, okay? And then I have to solve using some kind of we have to, it is called remainder theory, okay? So guys, did you learn remainder theory in your high school, like solving a 3 so here the highest power is 3, right? So solving a how to say it, second third order, so solving a third order equation. Guys, do you know how to solve this? I mean, using the remainder theory. you just need to input some value, like here is 1. So for example, if we have to think of some value, uh, if we input here 1, so we will get, so if we input lambda is equal to 1, so we will get the final result is 0. So we have to let some value for what the function value is 0. Okay, so as you see, I have written lambda equal 1, so I get the final value is 0. So according to the remainder theory, uh, according to the remainder theory, if f of a equals 0, then x minus a is a factor of f of x. So that's why I have written here x minus I have written here lambda minus 1, lambda minus 1 3 times, and then I tried to expand this, and I got lambda minus 1 into lambda square minus 9. So at the last, I got lambda 1 is equal to 1, lambda 2 is equal to minus 3, and lambda 3 is equal to 3. So if you still don't understand how to calculate, how to find the value using remainder theory, you can use online calculator. Okay, just okay. So here we have lambda cube minus lambda square. We have lambda cube minus lambda square minus 9 lambda plus 9. So if you use this online calculator, I mean factorizing, so I'll send the link here in the group. So if you write down this equation, lambda 3 minus lambda square minus 9 lambda, so I can see x cube minus x square, x cube minus x square minus 9x, 9x plus 9. So if you try to solve this, then you will get like x1 equal to, okay, evaluate. So see here, x minus 1, x plus 3, and x minus 3. So x minus 1, x plus 3, x minus 3. So I have written here on the last part, x minus 1, x plus 3, and x minus 3. So if they are equal 0, so I have to write down 0 on the right side, then it will give me the solution equal to 0. So you see here, x equal to 1, x equal to minus 3, and x equal to plus 3. So we got our solution. So this is the eigenvalues, okay? So this lambda 1, 1. So this value, oh, so this value, lambda 1, lambda 1, lambda 2, and lambda 3. So they are the eigenvalues, okay? So this way we solve the last question. Like this way we find the eigenvalue, okay? Guys, can you really understand? It was a long, mathematics. Guys, are you still there? Okay, so can you really understand this? How to find eigenvalues?
I'm not sure about it.
Okay, no problem. So this is some kind of hard topic. So still, if you know how to do the arithmetic process, then it becomes easier. Okay, so it takes a lot of practice to find a solution. So maybe you just can do the can follow the procedure. Like the procedure here is where I left. So the procedure here is the formula is modulus modulus a minus lambda I. So for lambda I can just write down. We take the main diagonal, and then we just write down minus lambda and minus lambda, okay, with the main matrix, and then we try to solve them, and then the main problem begins. So we have a lot of steps, and finally we end up with this equation, and then we have to solve this equation. I mean, we have to expand this equation. So like I have as I have seen as I have done here, we have to expand this equation, and then we will get something like this line,
Are you
and
on your
then
screen right?
use online calculator, and you will find the eigenvalue, okay. X1 is 1, x2 is minus 3, and x3 is 3. Sorry, Jem, could you please repeat?
Sorry, are you sharing your screen right now? Oh,
You are not sure about the eigenvalue?
or I missed. Yeah, I can see the screen. Are you sharing your screen or no?
Oh, okay. So, okay, sorry, I'm sorry. Maybe I just shared. Yeah, I have shared my screen. Can you see my full screen now?
Yeah.
So you see, as we got at the last step, so at the last step we got this equation, right? Lambda cube minus lambda square minus 9 lambda plus 9. So we take this equation in this Math Papa factoring calculator. Okay, I have given the link in the WeChat group. So just write down this equation here, and click on calculate. So you will get like the answers. X1 equal to 1, x2 is equal to 3, sorry, minus 3, and x3 is equal to 3. So this 3 is our eigenvalue. So 1, minus 3, and 3, they are our eigenvalue. So I have written here lambda 1 is equal to 1, lambda 2 is equal to minus 3, and lambda 3 is equal to 3. Okay.
Oh, okay.
And do you know remainder theory? How do we calculate?
No,
Oh, okay, so no problem. It was back in our high school, or maybe those who took science, they know how to calculate some equation using remainder theory. So, and then at the last topic, we will see how we can find the RREF form, okay? Manually, not using the calculator. So we can start with this problem. Maybe this one. No, not this one. We saw this. Yeah, this one. Number four. So as you see here, I calculated using a online calculator, but I'll try to show you how we can just convert this equation into this form, okay, RRF form. So I need to write down this in a clean paper. 2 1 minus 3 on 4. 2 1 minus 3 on 4. 1 2 minus 1 4 4. So I'll suggest you a video, I mean a playlist where they have explained much better than me, okay? So how do you find the RRF form? So 2 minus 1. That will be really helpful if you want to learn the procedure. I also learned from there, okay? Because our Laoshi, she didn't explain. I mean, she tried, but I couldn't understand his lesson so well. 30 minus 5 minus 2 5. Our Joe Laoshi was perfect. Oh, okay, no problem. Mitchell, so thank you for joining. I already shared my screen. You must see. So Jem, can you see this? Okay. 2 1 minus 3 1 4. 2 1 minus 3 1 4. On 2 minus 1 4 4. On 2 minus 1 4 4. 3 0 minus 5 minus 2 5. 3 0 minus 7. And then 5 1 minus 8 minus 1 8. 5 1 minus 8 minus 8. So let's begin. Now we have to look here, like if we have some kind of similar entries, we have to start from there. And we see here we have 2 here, but okay, so we have on here, right? We have on here and on here. So we can simply do like this. This is our second row. So we can do this one, R1 minus R3, okay? And then we put the value in row 1, R1 minus R3, and then we put the value in row 1. And we can also do another thing like that is going to be R1 minus R, the same thing, okay? R1 minus R3, and then we put the value in row 4, right? Here is row 4. Okay, we can put the value in row 4. So then we will end up this way, like, so we are changing row 1 and row 4. And why I have written here this way, because row 2 and row 4, they have similar entries. So that's why I will get 0 here, and also I will get 0 here, and all other entries, they will remain same. I have changed here and here, okay, in the second row and the fourth row. So let's do the changes in other rows also. So R1 minus R1 minus R3, right? So 2 minus 4, that is going to be minus 2, and then 0 minus minus 2, that is going to be 2, and then 1 minus minus 1, that is going to be plus 1. Okay. Oh, sorry, not here. Oh, sorry, I'm sorry. We have to make change on the second row only. Okay. We have to make change on the second row and on the fourth row. So the first row and the third row and the fifth row, they will remain the same. So 1, 3, and then 5. So here minus 1, minus 5, and then minus 8. And here, I mean, I'm just going to copy the numbers, okay? So I'm going to copy the first row, third row, and the fifth row. And I have to change the second row and the fourth row, right? So I have to change the, oh, I have to write here R2, okay? R2, sorry, R2. So I have to change the second row and the fourth row. So it will be minus 2, minus 4, it will be minus 2. Sorry, 2 minus 4, it will be minus 2, and 0 minus minus 2, it will be 2. And then 1 minus minus 1 to be plus 1. Sorry, plus 2, right? Plus 2. On minus minus 1 will be plus 2. And then the fourth row, on minus 1, on is 0, and 2 minus 4, that is going to be also minus 2. And then 0 minus minus 2 will be 2. and here it will be 4, so it will be 2, right? Yeah, 2. So now we have a 0 here and here, right? So let's see what can we do further. So okay, if we look here, sorry, just mention. Now let me change the color. Now if we look here, we have -2 here, right? So we have to make this way, like from the left side and from the downside, we have to make this way as 0, as much 0 as possible. Okay, so if we multiply 2 with the second row, so we will get 4, right? But before that, multiply 2 with the second row, and then okay, so if I multiply 2 with the first row, and then uh, subtract the first row from the fifth row, so I will get something like 0 here. Okay, so our target is we have to make this, we have to convert this to, we have to make some kind of identity matrix, right? And this entries, it will be 1, and all the entries below this main below this pivot point, it will be 0. So okay, so we can do another thing, like we can just divide 2 here. Okay, we can divide 2 with the first row. So if we divide 2 with the first row, then we will get on here, right? So let's do that. So 2 by 2 is 1, and then on by 2 is on by 2, and then 3 by 2 is 3 by 2, and then it will be 5 by 2. Okay, so this is the first entry of the first column, or of the first row, as we are going to multiply 2, we are going to divide by 2 with the first row, so it will be this way, and we keep all the entries same. Okay, we keep all the entries same before, and then so assume that, let me erase this. Okay, because I am not going to write down all those parts again. Oh, sorry. Yeah, so I mean, now our first row, it is going to be, it is going to be 1, 1 by 2, 3 by 2, 5 by 2. 1, 1 by 2, 3 by 2, and 5 by 2. Okay, so now you see, if I multiply, so you see we have 4 here, right? And we have on here. So if I multiply 4 with the first row, so I will get 4 here, right? And then I subtract the first row from the third row, or then I do this way. So I do this way: R4 into R1, and then minus R5, right? So I will get a 0 here, right? So I will substitute the value in row 5. So I will get 0 here, right? So this way,